Hello and welcome to Bevy Basics. I am up to part 4 of my user input series, and in this episode we will be covering gamepads. In most cases, when you're designing a PC game at least, you will be using keyboard and mouse as your primary user input. But there are a variety of games, such as twin-stick shooters and flight simulators, or just a particular niche of player themselves that prefer to use controllers and gamepads in order to interact with the game. For this reason, Bevy includes the ability to collect user input via gamepads. In this video, I'll be covering the basics of how to get user input from the gamepad. I'll be covering Gamepad Buttons, Gamepad Axis inputs, the Gamepads Resource that Bevy provides, how to configure the settings for the gamepad input, the gamepad events that are provided by Bevy, and some examples of where this code might be used and how to interact with it. Like all the other user inputs, Bevy provides this functionality by including either the inputs plugin or the defaults plugin into your application. Inside Bevy's prelude, you'll find the Gamepad button type enum. This enum denotes all the common buttons you'll find on a standard gamepad, such as trigger 1 and trigger 2, both on the left and right side, the north, south, east, and west face buttons, the up, down, left, and right D-pad buttons, pushing down on the thumbsticks, start, select, and mode buttons. Depending on the controller that you have will change where these buttons are located and how you may interact with them. Additionally, Bevy has access to the C and Z buttons, which the best I can find are more specialized buttons that existed on things such as the GameCube controller had C and Z buttons. This enum is used in conjunction with Bevy's input struct in order to get access to direct button pushes as a binary value. This is interacted with in the same way that you would do for keyboard and for mouse clicks, and was covered in more detail in the first part of this series. But for some reason, Bevy also includes inside a button the triggers, which return an analog output of how far the trigger has been pulled. For this interaction, Bevy provides the Axis struct as a resource that, when accessing the buttons, will allow you to return a float value for the button. This represents how much the button has been interacted with. For all the regular buttons, this is either 0 or 1, indicating whether the button is pressed or not. But for the trigger buttons, this value is pulled. It is important to note at this point, because the triggers can be pulled, they have threshold values that are set in a settings that I will talk about later that indicates whether they show up as just press or just released in the input struct. Bevy also provides, in its prelude, the Gamepad Axis type enum. This enum represents the more analog inputs on your controller, such as the X and Y motion of the left and right stick, and the Z and D-pad X and Y motion. The bottom set that I mentioned of Z and the D-pad motion is more additionally for non-standard controllers like flight sticks that have additional axes, or gamepads that have a D-pad that registers not binary inputs, such as tilt pads. Bevy exclusively provides the Axis input type for this particular enum. To use these enums, you need to wrap them in the Gamepad Axis, which is just the gamepad identifying number and then the Axis type wrapped together as a new type. There is no input resource for this particular type, as for some reason Bevy considers analog sticks not to have an active or deactive state, so they only return the float value. Bevy provides a Gamepads resource. This resource can be used to determine what gamepads are currently connected to your game and is accessed in a system parameter simply as res gamepads. This will automatically register and unregister gamepads as they are plugged in or unplugged. Bevy also provides a gamepad settings struct that can be inserted into your game at startup in order to enable you to configure how the buttons react. Bevy provides these settings in such a way that they meet the standard for game controllers that your manufacturer should send, such that button settings set an analog threshold high and low. Most game controllers, this is not necessary simply because they send a binary 1 or 0, but if you had an analog switch that you were turning into a button input, it would need these thresholds. When setting up the settings, there are 3 different settings that can be configured for each of the button types. There is the button settings, which provides a pressed and released threshold for analog inputs. This in most cases doesn't matter because your controller will only send a binary on-off signal. Then there is the Axis settings. This has 5 floats that can be specified. The positive high, the positive low, the negative high, and the negative low. These values are all associated in that the positive, high, and low are the range in which the high value will actually be returned. If it is above the high, it'll be returned as 1, and if it's below low, it'll be returned as 0. This allows for a binary switching of the controller once it reaches a certain threshold, or a dead zone in the center. The same applies for the negative. The threshold value is used to update the events based on how much the controller needs to move before a new event will be fired. This means that if you set this value to something such as 0.1, there will only be 10 discrete steps between pushing the controller from the center to fully extend it. Button axis settings is the same as the axis settings, but reduced because the button axes only have one direction of motion. So they simply have the high threshold and low threshold, which are rounded up to 1 or down to 0 accordingly, and the threshold representing how much the controller needs to move before it will fire a new event. As of the recording of this video, Bevy does not allow you to edit game settings once they have been inserted, and you will need to reinsert new settings after the game has started if you want to change these at runtime, or specify a specific key that needs a value. All this needs to be done at the insertion of the resource, or by manually editing the hash maps. There are no convenience insert or remove functions provided. Hopefully in the future, Bevy will extend these functions that it provides for the gamepad settings to allow you to insert these settings. Bevy provides the gamepad event type, which simply consists of an enum of connected, disconnected, button changed, and axis changed, which holds the button type or axis type respectively, and the amount that value is changed by. Bevy allows you to access these events in 2 distinct ways, either as the event itself or as the raw event. The key difference between the gamepad event and the raw event is that the event runs through the filter of the threshold first, whereas the raw event will represent every single output from the controller. It is important to remind you at this point that all gamepad interactions are new types that wrap the gamepad identifier and the button or event type together. This is not necessarily obvious and can lead to some confusion. Now I will show you some basic examples of what is printed to the console when you are interacting with these events. If you look in the description, you'll find a link to my GitHub repository for Bevy Basics, and in there you'll find the example for input events. If you set the enum for initializing these input events to being gamepad button pushes, you'll enter this mode of the thing. From there, any press on your controller will represent the gamepad button. As seen, printed out in the console is the gamepad button, followed by the gamepad that was sending the event, in this case gamepad 0, for I only have one gamepad plugged in, and what button is being pressed. When I use the triggers, it will print out the analog value held by the trigger, and then also when the trigger is pulled all the way past its threshold, the firing event that is responsible. If you then press page down, you will enter gamepad event mode. In this mode, I am printing out both the raw and the gamepad events together. As you can see, for single button pushes, this will simply print out the raw event and gamepad event together, simply representing that they are the same event. But for something such as a trigger pull, you will notice, if you want to read through that wall of text, that there are significantly more raw events than there are gamepad events. This is because the gamepad events are only emitted when the threshold is passed, which in this particular case is about every 0.1 of a motion. As you can see here, the raw event is fired multiple times between the firing of a gamepad event because the threshold has not been reached. The final mode, if you press page down again, will put you into Gamepad Axis mode. In this mode, moving around the joysticks will print out the joystick readouts from the Axis resource. It is important to note that currently, at least with the controller that I have, the only outputs that Bevy will respond to are the thumbsticks. As despite the fact that Bevy has D-pad in its Axis selection, they do not actually do anything in my current configuration, and I'm not sure why they're there. That is basically all the user input that you can get from a controller as of the time of recording this video. Thank you for watching this video. It'd be appreciated if you like, comment, and subscribe. Before you go, if you could please leave a comment on your thoughts on the inconsistency of Bevy's gamepad controls compared to its other input systems. Personally, I'm going to put an issue forward in Bevy asking why exactly the axes are split from the buttons, especially considering that one of the buttons is in fact itself an axis, and why they don't just simply have the input for gamepad and the axes for gamepad, distinguishing between whether you want a binary response for if the button is pressed or trigger is pulled, and the axes for when you want to read the direct analog output. This seems like a much more intuitive way of recording gamepad input. The only reason I can think that Bevy would do these distinctly different is if the standard that controllers are designed to send, which I believe is the same standard that VR controllers send, is specified in such a way that Bevy can't do this. Hence, I am going to post an issue, and there will be an updated video if this gets changed in the future. Thank you for watching. Like, comment, subscribe, and I'll see you in the next episode where I do touchpads, where I have more bitching.